Today we're going to be talking about the law of sines. This is something that you did learn last year in geometry, but we're going to delve a little bit deeper into it. Here, these are used to solve non-right triangles, or we call these oblique triangles, where they are in the form angle, angle, side, angle, or angle, side, side. But you need to watch your mouth and be careful, and we'll talk about that a little bit later on. So these are for non-right triangles. Obviously, if it's a right triangle, you can use right triangle trig and you're good to go. So what do we know about triangles in general? The largest side is across from the largest angle. The angles must add to be 180 degrees. There can be no more than how many obtuse angles? So there can be no more than one. We know that obtuse means that it is over 90 degrees, and if they're equal to 180 degrees, there's no way to have more than one of those. And then that means that there could be how many acute angles? So you could have 2 or 3. It could be the case that none of your angles are obtuse and that they're all acute. Okay? So what does the law of sines say? This says that all of the ratios of the sine of an angle to its opposite sides are equal. So if you're looking at or thinking about a triangle, and let's just draw one in general here. If we have triangle ABC, the side across from angle A is side A, and then the same thing with angle and side B and angle and side C. So the law of sines just is a big proportion here of the sine of the angle over the corresponding side is equal to each thing. So the sine of angle A over side A is equal to the sine of angle B over side B is equal to the sine of angle C over side C. So this is really important for you to know. It is just a bunch of proportions. All right, so let's actually look at a situation where we have angle, angle, side. Okay, so when it says solve the triangle, that means that you need to find all of the missing pieces to that. So I've already gone ahead and placed the information that we know for sure in the question. And this is how I like to set up my work or my answers. That does not mean that that's what you have to. Some people like to draw the picture of it and then fill in to the picture as they go. Okay, so we do know that for law of sines, we need to have an angle side pair. So that means that I know angle A and side A. And so then I need to figure out what side B is first. Actually, before we even do that, we know that 180 degrees, there's 180 degrees in every triangle. So if we take 180 and subtract the 39 and the 32 degrees that we already had, we know that this angle here is 109 degrees. Okay, so we also know that. All right, so moving forward here, if we're trying to solve this, this is a proportion. So we know that B sine 39 is equal to 40 sine 32. And if we're trying to get B by itself, we would take that 40 sine 32 and divide it by the sine of 39. Okay, and that's what we're going to type in the calculator. So we have 40 sine 32. Don't forget to close that parenthesis, divided by the sine of 39. And that's going to give us 33.682 feet. Now, I know I've talked about this a little bit in the past, but we do want to store these values. It's not going to matter so much for this question, but it could in the future. So the way we do that is we hit store and then alpha and whatever we're saving it as. So since this is side B, I'm going to save it as side B, and then it's there. It's good to go. Okay. The next thing we have to find, obviously the last thing here, is side C. So we know we want to use the A information because that is information that they gave us to be true. If we made a mistake in getting this, then obviously if we used that mistake, it would give us a wrong answer here. So we're going to set up our proportion, which is this. Now, you can do it this way if you want, or you can just jump straight to this. So I know that C would equal the two that are on the cross together, so the sine, 40 sine of 109 divided by the sine of 39. Okay, it's kind of up to you. So again, we're going to the calculator here, and we would type in 40 sine 109 divided by the sine of 39. And so that means that our third side would be 60.0 3.98 feet. So we're going to make sure that we're putting units with these things and we're rounding to 3 decimal places. Okay. Since we're done with this question, we don't need to store that one. You could if you wanted to. All right, well, let's take a look at our next question. So another type of triangle that we could use is angle, side, angle. So I guess I should have said this back here. We have angle, angle, side. All right, those were ways that you could prove two triangles congruent in geometry. Angle, side, angle means that you have angle, the side in between, and that and another angle. So angle, side, angle. It doesn't have to be exactly this setup, but you would have that. All right, so if we have two angles, we're going to go ahead and find the third angle first. So we have 125 degrees between those two things, which means our last angle would be 55 degrees. Okay, now it's kind of up to you in terms of what order you solve for things in. Typically, I kind of work in alphabetical order. There's nothing that says that you have to do that. Going back again really quick for a second to kind of double check things. The largest side should be across from the largest angle. And so as we're going through, that does work all the way down to the shortest side across from the smallest angle. Okay, so let's go ahead and find angle or side B. So that means that we need the sine of 55 over 40 equals the sine of 25 over B. And it doesn't matter which side this is on. So we know that we have 40 sine 25 over the sine of 55 would give us our answer for this. So, and that's going to give us 20.637 feet. And then we're going to do the same thing again to find side C. So I'm going to use that sine of 55 over 40 because we're positive that that's the correct answer and they gave us that 40 to be true. Okay, so then C would equal 40 sine 100 over the sine of 55. And I know I'm going really fast through this. Remember, you can pause your video and rewind or whatever you want to do as you're going. So we're going to fill all this information in and we get 48.089 feet. Now, I didn't save either of those values here. That doesn't matter all that much, but we will talk about here in just a second when you will definitely want to save things. Okay? So, moving on. Now we are in the case, the ambiguous case. So, ASS, you are never able to solve or prove two triangles congruent by ASS because that word would get you in trouble if you said it. So this means that we need to test to see if there are two triangles. Now, there could be two triangles for the fact of the unit circle, which we haven't learned about yet. So we'll talk more and delve into that at a later time. But this is what we would use to test. It's B sine A is less than A is less than B. We're not always given side B, angle A, and side A, but that is the test that we're going to modify as needed. So these middle letters are the same, and then these outside letters are the same, and that's how I keep track of how I'm going to test. All right, so we have, if this statement is true, this inequality is true, then we have 2 or 0 triangles that exist. That means that 2 triangles could exist, or using that information, no triangles could exist. So for example, if I use this marker, I use a paper clip, and I use a yardstick as my side lengths, there's no way to make that work to make an actual triangle. So that's where no triangles. If it's false, then either 1 or no triangles would exist. Typically, it's going to be 1 in that case. All right, so we have to test here first. Now, they give us angle B. So I know that it's got to be the sine of angle B. The side across from that is going to be directly next to it because these letters need to be the same. And then the other side length that they give us is going to go on the outsides. So first I'm going to test is 11 less than 15, because if that's not true, then I don't need to do any more work. Since that is true, we actually need to do some math here. So we have 11 sine 35. That's 6.309. That is less than 11, which is less than 15. So there's either 2 triangles or 0 triangles. And how you're going to know the difference? You got to start doing some work. All right, so our first triangle. From here, you're solving this exactly like you would in the past. So even though there are 2 triangles or no triangles, you're still going to solve this exactly as you would in the past. So I'm going to change colors here. And the next thing that we're going to have to find, the only choice that we have is to solve for angle C. So we have the sine of 35 over 11 equals the sine of C over 15. So here, the sine of C would equal 15 sine 35 over 11. So to get that angle, we're going to do the inverse. So angle C would equal sine inverse of this stuff. All right, so we're going to type all this in. So we have sine inverse of 15 sine 35 divided by 11. All right, so that means that angle C is 51.458 degrees. This is where it's going to be important that you're storing things. So I'm going to store this as C. Now, I know that 2 triangles have to exist here. I know that because I'm getting an actual answer here. If I don't get an answer here, that means that the third triangle or the second triangle, no triangles exist at all. Okay, so we've got this. Now to find angle A, we're going to take 180 minus the 35 minus that angle C that we just got. So we have angle A to be that. And I'm going to go ahead and store that as angle A. And then to find side A, I know that the sine of 35 over 11 is going to equal the sine of, I'm just going to put A in there for right now, over A. So A is going to be 11 sine A over sine of 35. Now, when you're trying to grab these things from your calculator, we have 11 sine, we're going to say alpha A, or whatever letter you're choosing, in this case, all right, divided by the sine of 35. So that's going to give us 19.141 feet. So the biggest angle is across from the biggest side. Now, to get to that second triangle, okay, the same information that they started with here is going to still be true. So this is all the same information that they gave us in the original question. So to find this, we're going to find this angle here by taking 180 and subtracting the first angle C. Angle C in this case was because that's the first angle that we found in the first triangle. We had to find C first over here. That's why we're doing 180 minus the first angle C. If we found A first, we would do 180 minus the first angle A to find that second triangle. Okay, so we're going to do 180 minus the C that we had saved. So that means that our new angle C is 128.542 degrees. So I'm going to store this as C. If you don't want to store it over as C, you can choose a completely different letter to save it as. So now we're going to take 180 and subtract that C and the original 35 to get 16.458 degrees. The last step here is to take this and do your law of sines again. So I'll come up here with this. We have the sine of 35 over 11 equals the sine of A over A. That means back here I want to store this as A. That was my new angle A. So A would be 11 sine of A divided by the sine of 35, which is going to give us 5.433 feet. Okay, again, you have to test if it's angle side side. If you test this and it is not true, it is no triangle, and you automatically move on to the next question. All right, and that's it.